Hello guys. Um, we are getting to the next quiz, and that is for the non-homogeneous case. Okay, so the homogeneous case we did already, but we need to know this for a non-homogeneous case as well, right? Remind you how it goes. I'm going to do two examples. That's the first one. Let's consider this recurrence relation. A(n) is minus 3a(n) minus 1 plus 4a(n) minus 3 plus 6 minus 2 to the power n. And then the initial conditions are a0 is 4. How many should I give? You can tell already because this is degree 3, right? So, okay, here are the 3 that I give you. Okay, so, since we said this already, let's figure out the degree is 3 because we have to go back 3. Okay, right, it's non-homogeneous. This is the non-homogeneous part. So the first thing we need to do is solve the homogeneous one. The corresponding homogeneous one, that is a(n) equals minus 3n minus 1 plus 4a(n) minus 2. We know that we have to start with r cube and then go descending powers, that is an r squared. Now be careful, there's no a(n) minus 2, oh sorry, minus 3, right? There's no a(n) minus 2, so that means there's no r, but there is a constant. 4. Okay, I know these numbers sometimes get a little bit, we might get confused a bit by these numbers. Okay, that's the way it goes. Right, so r cube plus 3r squared minus 4 equals 0. We know that we have to look for the divisors here of this guy, are plus or minus 1, plus or minus 2, and plus or minus 4. We try the first one and 1 already works. 1 plus 3 minus 4 is 0, so r is 1. Checks out. That means that I can do long division. R cubed plus 3r squared minus 4. I put it here because actually there's an r term that will appear in the quotient. So divide now by r minus 1, right? So we know that this can be factored. No, sorry, not here. That this guy can be factored as r minus 1 times, and then what is this thing here? Then that's going to calculate, that's going to come here, right? Okay. So how many times does r goes into r cubed? R squared times. We multiply r squared with this whole thing, we get r cubed minus r squared, and then we subtract, which is changing the signs and adding. You can subtract if you like subtracting. So that is 4r squared. How many times does r go into 4r squared? 4r times. Okay, so this we multiply 4r now with r minus 1. That is 4r squared minus 4r. Again, we subtract, so that means, okay, change the signs. So that is 4r, and then we have the minus 4 there. So how many times does it go in? 4 times again, and so we get, if I multiply 4r minus 4, and if I subtract, everything gets 0, which is exactly what it should be. So we find that our characteristic equation is r minus 1 times r squared plus 4r plus 4. But that actually factors as r plus 2, right? So r plus 2 squared is a double product formula, and it's important that we write it that way, not just r plus 2 times r plus 2, because we need the multiplicity. So r is 1 has multiplicity 1, but r is negative 2 has multiplicity 2. That is very important for what follows. For one thing, it's important to write down the homogeneous solution. The homogeneous solution is we take each of these roots, so 1 to the power n and minus 2 to the power n, and then in front of here we put general polynomials of degree 1 less than the multiplicity. Okay, so here we subtract from the multiplicity. So don't confuse with what happens in the non-homogeneous case that we're going to get to shortly. So here we get multiplicity 1, so it means degree 0, that means just a constant, alpha. And here we have multiplicity 2, 1 less is degree 1, so we get beta plus gamma n. So let's write it down a little bit nice, because what would be done we don't write. Okay, so that is how our homogeneous solution looks like. So step 2, the particular solution. So now we analyze the non-homogeneous part, and that is this part here. So f of n is 6 times minus 2 to the power n. Be careful, don't say that it's the same as minus 12 to the power n, right? 6 is a constant that is outside, it's not raised to the power n. So we have to analyze this a little bit. What is s? Let me write my s in the way that you can do. What is this? What is this? S, the multiplicity of s and the degree. What is s here? S is negative 2, right? That is, what is s? S is whatever exponential function you get here, the base of that. Okay, that's minus 2. What is this m then? Well, that is the multiplicity of this guy in the characteristic equation, which we know is 2. So m is 2 here. And d, that's the degree, and be careful, that's not the degree of the recurrence relation, that's the degree of this polynomial in front, which is degree 0 here. So then we know that the particular solution will look like, well, the s, that is going to be, again, we're going to have the same exponential function, minus 2 to the n. What does the n do? What we get from here, this is n to the power m, so n squared here, that will come. And then here we will get a general polynomial of degree 0. Don't subtract or anything, a general polynomial. What does that mean? Well, a constant, and the general constant is a. So this is how my particular solution looks like. Okay, a little bit nicer written is this. What do? We have to now plug this into the original equation. So into this equation, the original one. Okay, let's see whether I can actually copy it. So I'm going to copy this thing again. Sometimes it works, sometimes it doesn't. My n is not going to get in there, but let me do it one more time. Okay, and then I do copy, and then I do paste. Okay, and then I can move it around here. Okay, so let's plug it in. I'm going to put this in here, right? So that is a n squared minus 2 to the power n. That is the a n here. Now I have to do here equals minus 3, the same quantity, but in replacing n by n minus 1. So that is a n minus 1 squared minus 2 to the power n minus 1 plus 4 times a n minus 3 squared minus 2 to the power n minus 3, and then of course that homogeneous term is just something, the non-homogeneous term is just something I copy. Okay, so first thing we need to do to make this simpler is divide out. This we do whenever we have an exponential part. In other words, when s is not 1, then it's not there, but if any other circumstances, we need to get rid of those exponentials by dividing the lowest one that occurs, that will always be the one that comes from the last term in the recurrence relation, the homogeneous part, right? So I'm divide out minus 2 to the power n minus 3. That means that in the first term here, there are going to be 3 left, 3 powers left. So we have a n squared, and then minus 2 to the power 3, that is minus 8, equals minus 3a. I'm going to already expand this, and let's do it minus 2n plus 1. And then how many are left here? Well, 2 powers, that gives me a 4. So this constant in front of it would be 3 times 4, that would be 12, right? So I'm saying this, if I take the third power here, that would be minus 8. If I take the second power here, is 4. And here I would take nothing, everything is out, so I just get the 1 here, and here again I would get a minus 8, right? Okay, so that's that. So here we said everything comes out, there's nothing left anymore with these powers of n of 2, but we have still this guy that I want to expand by the double product formula. And then here we had a minus 8 times 6 is minus 48. Okay, and now we can gather the coefficients on each side, because they have to be the same. If we look at the constant terms, on the left hand side we have 0. What do we have on the right hand side? Minus 12a plus 36a, right? This is this one, of course, there's minus 12 and 4a in front of it, and minus 48. Then the term of degree 1, there again, there's nothing on the left hand side, so its coefficient is 0, but we have something on the right hand side. We get 24a, right? That is this one. And here we get minus 24a. And that's it. Oh, that's nice. It's 0. Remember, some of these things have to cancel. So good news. What do we have here? We get minus 8a, the term of the square. Here we have minus 12a, that's this one, and plus 4a, that's this one, that is minus 8a. Oh, nice, again cancels. Yeah, because there's only one unknown. I cannot have three different equations, because then I can never find the solution. So that's good. So we find here from this minus 12, so this we see that 48 is equal to 24a, right? 48 on one side. And so we see that a is equal to 2. Oh, that's good. We have our particular solution, but that's not necessarily the correct one. We have to now, to find the correct one, we add the homogeneous plus the particulate. Okay, the homogeneous one was this guy here. Okay, so alpha plus beta plus gamma n minus 2 to the power n. Plus, and now we add the particular solution, that is this guy here, that is 2n squared minus 2 to the power n. So what remains is alpha, beta, and gamma, and that we do the initial conditions, right? This is where they come in, all the way at the end. Be very careful with that. Don't do it too soon. Don't do it when you're dealing with homogeneous one yet, because that's not what we want. We don't want the solution of the homogeneous one, we want the solution of the actual one, the non-homogeneous one. Okay, so the initial condition, if n is 0, I copied it down here, then it's 4, right? 4 is equal to alpha plus, we have a beta there, the gamma cancels, and that last time also cancels, good. If n is 1, I get, what was the minus 5, I think? Where did I write it here? Minus 5, and the other one is 27, let me write it down. Minus 5 and 27. Okay, if I plug in 1, I get alpha plus beta plus gamma times minus 2 plus 2 times minus 2. Okay, let's work this out a bit. This is alpha minus 2 beta minus 2 gamma, and that is minus 4. So I would bring that to the other side. I would get, let's give myself a little bit space here. You bring this to the minus 4 to the other side, and we get minus 1 is equal to alpha minus 2 beta minus 2 gamma. Okay, and then 27, that is when we plug in 2, we get alpha plus beta plus 2 gamma minus 2 squared, that is 4, plus 2 times 2 squared, that is 4, times minus 2 squared, that's another 4. Okay, be careful, right? Everything has to be plugged in here. So that would be 27 is alpha plus 4 beta plus 8 gamma plus 16 plus 32, so that we get negative 5 there. So negative 5 is equal to alpha plus 4 beta plus 8 gamma. So we have our equations, this one, and this one, and I'm going to use elimination on using alpha. So I'm going to use the multiply. These are the two things I'm going to do it in different colors. If I multiply this with minus 1 and add up there, and I do the same thing there. Okay, it's twice the same. So that the first time, if I multiply my 4, that's minus 4 plus minus 1, that is minus 5, equals the minus alpha plus alpha cancels, minus beta, minus 2 beta, so minus 3 beta, minus 2 gamma, there's nothing there. And then for the second one, I do minus 1, that's minus 9, equals the alphas cancel, minus beta plus 4 beta, that is 3 beta, and then plus 8 gamma. I can add those, so that is minus 14 equals 6 gamma. Sorry, the original condition, 47, so I said 27, I don't know where 27 came from, that was 47. This was 47, the initial condition, right? It's, where is it? Here. Okay, so sorry, that's 47. That what is then? Okay, so that would actually be not 47 minus 32. That would be plus 15 here, right then? Right? Yes. So plus 15. So when I add it, minus 4 to 15, that would be actually 11 here. Sorry. And then if I add those two, I would get 6. Yeah, it is so easy to make mistakes, right? 66 gamma. I knew the numbers were nice, so that's why I knew there was something wrong. Gamma is wrong. I cannot always promise that. So just if you have small fractions, don't think, oh, I'm wrong. Okay, big fractions, ugly fractions, or weird numbers, yeah, that's most likely not correct. But fractions sometimes are inevitable. Okay, so gamma is 1. We got that. So once we get gamma is 1, I can plug that in here. So minus 5 is minus 3 beta minus 2. Then bring that to the side and get minus 3 is minus 3 beta. Also beta is also 1. And then once I have all that, I can plug that into this one here. So that 4 is alpha plus 1, so alpha is 3. Okay, so the solution is AN is alpha. Okay, I'm going to write it here, otherwise I'm going to make copy error. So the solution is, so here, this is the box solution, right? It's going to be alpha, that was 3, right? 3 plus 1 plus n minus 2 to the power n plus 2n squared minus 2 to the power n. Quite a mouthful, right? But okay, that's how it goes. Okay, that's one of them. You see, it takes a little bit of time. 15 minutes, but you have the whole day. Take your time, check all your calculations very carefully. It's very easy to make mistakes, so I would really suggest to go over it twice and also double check, is this now, does this make sense? What you could do, for instance, is say, okay, let's see whether the initial conditions are satisfied by this. Or even, we could even go one further and say, let's calculate A3 and to check that everything works. But okay, that's perhaps a lot of work to do. Okay, so I'll do one more here. Let's do this one. AN is equal to 3 AN minus 1 minus 4 AN minus 3 plus n to the power n. And the initial conditions are A0 is 2, A1 is minus 1, and A2 is 1. Okay, and I'm going to already copy this for myself that I can later paste it. Okay, so first thing, what is the degree? Oops, the degree is 3, that's why we have 3 initial conditions, so everything works. Step 1, the homogeneous one. The homogeneous one is AN is 3, AN minus 1 minus 4, AN minus 2. It's very similar than the previous one, if you think about it, because we get r cubed equals 3 r squared minus 4. The signs are a little bit differently, so we get r cubed minus 3r squared plus 4 equals 0. Again, 1 is a solution? No, 1 is not a solution, but minus 1 is. Right, because I get a minus 1, minus 3, plus 4. So I see that x, so r is negative 1 is a solution. R is 1, so r is 1, I get 1 minus 3 plus 4, so that doesn't check, but r is negative 1, I get negative 1 minus 3 plus 4, so this checks. So this is a solution, so I know that I can do long division, r cubed minus 3r squared plus 4, so we know that this factors, let me write this out here now, this factor is r plus 1 times a quadratic, so I have to divide by r plus 1, r squared times, it goes in there, r cubed plus r squared, we subtract, I'm going to do this quickly now, subtracting, okay, minus 4r squared, so we get a minus 4r times, r goes in there, so we get minus 4r squared minus 4r, I hope it's okay, right? You're following what I'm doing. Subtracting again, that gets a 4r. Okay, changing. We subtract the second from the first, so the minus becomes a plus. Okay, and then that goes in there 4 times. We get 4r plus 4, and we subtract. Well, don't forget there's a 4 here, so perhaps I should have written the 4 here. Then you see that everything cancels. There's a 0 here, which it has to remain the 0, and so we find here r squared minus 4r plus 4. But that I know how that factors. That is two numbers that multiply 2 plus 4 and add up to a negative 2, that's minus 2 and minus 2. So actually I should write it with combining the terms, but doing the terms in powers, because that tells me the multiplicity. So r is negative 1 has multiplicity 1 and r is 2 has multiplicity 2. That's important because the homogeneous solution therefore will look like minus 1 to the power n, and in front of that will be a general polynomial of degree 1 less than 1, that is 0, so alpha, plus, and here we get a general polynomial of degree 1 less, so 1 times 2 to the power n. Okay, so again, let me write a little bit nicer. That's alpha minus 1 to the power n plus beta plus gamma n to the power n. Okay, so now the particular solution, we have to analyze f of n. F of n is n times 2 to the n. N times 2 to the n. Okay, so what are we dealing with? S, m, and d. S is 2 here. Now the multiplicity of 2 in the acrostic equation is 2. So that is 2 here. And what's the degree here? We're talking about the degree of this guy, that is 1. So I know now that a particular solution will look like, this tells me that I have an n squared in front of that. Then this tells me a general polynomial of degree 1, that is a plus b n. And then this is 2 to the power n. So if you want to write this up, that is a n squared plus b n cubed to the n. Okay, the powers get a little bit higher, but it's not that a bad thing. So now I have to plug this into the original equation, which I still have, right? So I do, where's my copy game? Paste, where's my paste? Ah, yeah. Okay, come here, come down, get bigger. No, you get bigger, not. Okay, that's fine. Go away. Okay, so we plug this in, and then I don't know, that's a little bit big here. This one. Okay, so we have a n squared plus b n cubed 2 to the power n is 3 times a n minus 1 squared plus b n minus 1 cubed minus, not write it here, minus 4 times a n minus 3 squared plus b n minus 3 cubed. Oh, I forgot the 2 to the power, what power? 2 to the power n minus 1, and here is 2 to the power n minus 3, and then we have a plus n to the power n. Again, we're going to divide by this 2n minus 3, so divide out 2 to the power n minus 3, then have here an 8 left, so 8an squared plus 8bn cubed, I'm already expanding it, equals, here I have a 4 left, so 12, and inside I have an n squared minus 2n plus 1, plus a bn cubed minus 3n squared plus 3n minus 1, the formula for cubes. Yep, that's that. And then here we have nothing left. In this term we cancelled everything out, so we just have that. So let me write that down. That is minus 4a double product formula n squared minus 6n plus 9 plus b n cubed minus 3 times the square of 3, that is 9, so minus 27n squared plus 3 times 3, so plus 9n, and then minus 27. Oh, sorry, I did it the wrong way. Sorry. Let me do this again. So, what is it? It is the double product formula, the cubic formula. Let me write it up again here. It is a cubed plus 3a squared b plus 3ab squared plus b cubed. So here we have to have, with the minus signs, if you have minus signs, then I get a minus sign here, and I get a minus sign at in the end. So what we have here, we have 3 here, right? That is the b. B is 3 and a is n, so we get minus 3 times 3, that is minus 9n squared, plus, then we have 3 times a, which is n, and then sorry, I'm pointing to the wrong side. Yeah, so you have to, oh, I'm not even pointing, you don't see me here. This is where I'm going. So this one is 27. If you don't believe me, just work it out. And then minus 27. That's that. And then we have, of course, plus and 2 to the, oh, how much left? 8, right? So 8n. Okay, so we have all the coefficients, the constant term. There's nothing on this side, on the left-hand side. On the right-hand side, we have the constant terms will come from this, from that, and from that. Be careful, they're quite a lot. So that is 12a minus b minus 36a minus 27b. Okay? So I can combine this perhaps already. That is minus 24a minus 28b. Okay, that's the first one. So this is the constant term, the coefficient of, so this is for n to the power 0 if you want, here n to the power 1, okay? So what's the coefficient here? There's again 0 on the left hand side, on the right hand side, these we term now by terms that have these n's in there. So this one and this, not this one, this one. Okay, so we get minus 24a. This one has 3b. This one we have minus plus 24a. And this one we get plus 27b. Plus 27b. Right, okay. And then we have a plus 8. Don't forget, this is also this guy. Sorry, I forgot to underline it. Oh, the a's cancel. Good news. In fact, so I see already what my b is, but let's go on. N squared. In n squared, they have an 8a there on the left-hand side, and the right-hand side, the n squared terms. So they use a different color, perhaps. So these are the terms. This one, there's this one, there's this one, and there's this one. And there's nothing else here. So, yeah, okay. So we have 12a minus 3b. We have minus 4a, and we get a minus 9b. Oh guys, I see that I made a mistake, right? The 12, I forgot that I didn't distribute the 12 here. I see that my number, okay, sorry, I have to do this over again. I was going a little bit too fast, and that is not smart. So let's do this, let's be this a little bit careful here. So let's work this out a little bit. So that is 12a n squared minus 2n plus 1 plus 12b. See, that's what I forgot here. That is, I have a coefficient here 2 plus 3n minus 1 minus 4a n squared minus 6n plus 9 plus 4b n cubed minus 9n squared plus 27n minus 27 minus plus 8n. Okay, so let's do this now. So this is the power 0. Then we have on the left hand side, so this is 8an squared plus 8bn cubed. So that is a 0 there, there's nothing there. And here the constant terms are, so these are these guys here. So that would be 12a minus 12b minus 36a minus 108b. That's it. Okay. Then the power 1, no coefficient on the left hand side, and the right hand side we are dealing now with these guys. So that would be a minus 24a, a plus 36b, then a plus 24a, plus 108b plus 8, Don't forget, sorry, I forgot to align it, but there's also this one, right? Yeah, that's that. Oh, the a's cancel, that's nice. So we can simplify this, but okay, perhaps we should already simplify each of these. 12a minus 36a, that is minus 24a, minus 12b minus 108, that is minus 120b. Okay, here the a's cancel, and so we get 144b plus 8. Okay, the power n squared, we have an 8a in here, and what do we have here? So let's cover them a little bit. There's the n square here, there's an n square, there's an n square, and an n square. These are the only 4. So we get 12a minus 36b minus 4a minus 36. I distribute the negative 4 wrong. I write it as, this should be a negative 4. I'm so sorry about this. What am I doing? Okay, so this is a minus sign here. You see, you have to be so careful with these things. Eh? So again, so all these things that I've done so far were wrong. So let's do them one more time. I'm sorry. Okay, the constant term. That was 0 here. No, let me not put this line here. That was 0 equals. The constant term was 12a minus 12b minus 36a plus 108b. Okay, so that is minus 24a plus 96b. Okay, that's for that. The constant term, sorry, the linear term, there's no coefficient on the left. On the right hand side we have minus 24a. We get 36 plus 36b, we get plus 24a, we get minus plus, so minus 108b plus 8. Okay, so now it's still true, but this is different here, so we have now minus 72b plus 8. Okay, the squares. So that was the orange guys, that is 8a here, and on the other side it was 12a minus 36b, then we have a minus 4a, and minus is a plus 36b. These cancel, and oh, this also cancels, this becomes 8a, and so this becomes a void equation. That's what needs to happen, remember? There are 2 unknowns, we should only have really 2 non-trivial relations, and I think we have the 2 already, so the next one also should show me that cancellation. So the coefficient of m cube, that is 8b, so what are the coefficients of m cube? That are this one here and this one here. So let's see what we, let me do black. So what we get here on the right hand side, we have 12b, and a minus 4b, which is 8b. Okay. There's no condition, right? It all cancels out. And now we are gone. So we see that 0 is equal to minus 24a plus 96b. And that 8 is equal to 72b. So we see that b is equal to 8 divided by 72. That is 1/9. And therefore, what is A? Okay, so we have 24. A is 96b, that is 96/9. So we see that A is equal to 96 divided by 24 divided by 9. We can simplify a little bit. So divide by 12 here, then we have, sorry, that's not the following. Divide by 4. That's no, they cancel out. So there's a 4 left, right? So there's a 4 left then, yeah, 4/9. So where are we? This is our particular solution, right? So our particular solution looks like, where are we? Here. Our particular solution looks like, what was A? Okay, I'm gonna write it here. So the actual solution, like the homogeneous solution plus the particular solution, let's combine everything. The homogeneous solution was, where are we? Homogeneous is this guy here. Alpha minus 1 to the power n plus beta plus gamma n 2 to the power n. And then we have the particular solution here, where A is 4/9 n square plus 1/9 n cube 2 to the power n. I'm a bit surprised that we have these fractions 9 here, but I'm just going to go on. I'm not so sure now whether this, I think I might still have made a mistake somewhere, but I don't want to go over it then again. So let's look at the initial conditions. A0 is 2. So if n is 2, then A0 is 2, and that in there, plug that in here, I will get an alpha plus beta. That's it. If n is 1, then A1 was -1, and that will give me, let's see, there's a minus alpha here, plus beta plus gamma times 2, plus 4/9 plus 1/9 times 2. And then if n is 2, then A2 was equal to 1. That would be alpha plus beta plus 2 gamma times 2 to the power 2, that is 4, plus 16/9 plus 8/9, and that all multiplied with 4. Sorry. Yeah, so I think I made a mistake because I remember this coming out nicer. I might have made a copy error. See, if you don't choose the numbers exactly like they have to be, then or I might have made a mistake in my calculation here. That is also possible. Let's double check. So we have an 8 here, a 4 here, that's 12. I think the 12 are okay. That's a -4 there. Yeah, I think it looks to me correct now. So, did I copy anything else wrong? That's a 12, that's a 12. Minus plus, I didn't copy any of the signs wrong. -4, -4. Okay, and then here I did 12 minus. This also supposed to be a minus, and this should be a plus. Yeah, that is correct. And this here, the next one is the one where the fraction came from. And let's see, perhaps that is wrong. We have a -24, we get a 3 plus 12, that's 36. We get a minus is plus 24a, yeah? And then we get a minus 80 and 28, that is 108, right? Yeah, and then plus 8. Yeah, I think it's correct, and this one gives me, okay, so it is what it is. So all right, so it gets a little bit nasty now because okay, so this is what this is. This whole thing is 10/9, right? This whole thing is 24 times 4, that is 80, that's 96/9. So we get 2 is equal to alpha plus beta. Then if this 10/9 is brought to the other side, that is -1 minus 10 over 9 is equal to minus alpha plus 2 beta plus 2 gamma. And I bring this 96 to 9 over the other side, that is 1 minus 96/9, that is alpha plus 4 beta plus 8 gamma. And now we can use elimination, so this would be minus 19 nines, and this would be 9 minus 96, that would be minus 87 nines. And then if we add everything, the first two, there's 2 minus 19 nines is 3 beta plus 2 gamma. And now I'm subtracting this from that. That is 2, so that is 2 plus 87 over 9 equals minus 3 beta plus 8 gamma. Okay, so this 80 minus 19, so this minus 1 ninth. Okay, this is minus 1 over 9. This is 18, and this is 105 over 9. So now I subtract, so this is minus 1 9, this is 105 9. So I subtract both, so I get at the bottom here, what I get is 105 9 minus minus plus 1 ninth is the betas cancel, and I get 6 gamma. So that is 106 divided by 9. That's not possible, right? So gamma is 106 divided by 54. And so we can follow the other ones. I think I took this as from a homework problem, and that is why some of these homework problems get very ugly. I apologize for the numbers. I thought the numbers would be nicer. I make sure that you get nice numbers. I hope see what to do, right? Once you have gamma, you can plug it in set here, and you find beta. It's a little bit of working with fractions. And once you have beta, you plug it in here, and you find alpha, and then you're done. Okay, so apart from the fact that the numbers are a little bit ugly in this thing, which I guarantee you won't have, not as ugly as this, then I hope it's the principle that how it works, right? That matters.